From past experience, we know that an equation such as y equals 2x plus 3 is a straight line. Also from past experiences, we discovered that squaring the base x will turn the line into a curve, specifically a parabola. But what form would a line on a graph have if the exponent is the variable? Making the exponent the variable, the shape is a curve that climbs or increases rapidly. Naturally, we call this type of curve exponential growth. This particular equation is y equals 2 to the x. Exponential curves have variations. If the coefficient is negative, a curve such as y equals negative 2 to the x will send the curve the opposite way, towards the negative side. And a decimal base such as y equals 0.5 to the x will make the curve decrease or drop rapidly. This type of curve is referred to as exponential decay. Let's see an example for exponential growth. On her birthday, a 5-year-old received a $5,000 gift and her parents placed the money in a bank account that earns interest at 7% per year. This means that every year she will receive 7 cents for every dollar deposited. How much money would be available in the account when the girl turns 20 or 15 years later? After the first year, $1 would have grown to $1.07. And after the second year, the $1.07 would have grown to $1.15. And after the third year to $1.23, and so on. This problem fits the exponential growth pattern because the more interest is accumulated, the higher the interest earned. In other words, the money grows rapidly by compounding on the interest already earned. The exponential equation would be y equals a times 1 plus I to the x, where y is the final amount, a is the initial amount, I is the rate of interest per period in decimal form, also known as the percent, and x is the number of periods, in this case, years. Solving for y equals 5,000 times 1 plus 0.07 to the 15th power. Because multiplying 1.07 to the 15th power is tedious, we use the y to the x function of a scientific calculator. Again, we use the TI-35X calculator. Press 1.07. Press y to the x. Press 15. Press equal sign. Multiply answer by 5,000. Y equals 13,795.16. The girl at 20 will have $13,795 with 16 cents. She earned $8,795 with 16 cents in interest. Let's do an example in exponential decay. A chlorine solution decays 50% or half for every week it is left uncovered. If the original amount of chlorine used is 2,560 ounces, or the equivalent of 20 gallons, how much chlorine is available in the solution after 12 weeks? If it decays 50%, half the amount, every week, after the first week there is only 2,560 ounces divided by 2, or 1,280 ounces left. After the second week there is half of that, or 640 ounces available, and so on. This problem fits the exponential decay pattern because the amount of chlorine drops rapidly. The exponential equation would be y equals a times 1 minus I to the x, where y is the final amount, a is the initial amount, I is the rate or percent of decrease per period in decimal form, and x is the number of periods, this time in weeks. Solving for y equals 2,560 times 1 minus 0.5 to the 12. Because multiplying 0.5 to the 12th power is tedious, we use again the y to the x function of the TI-35X calculator. Press 0.5. Press y to the x. Press 12. Press equal sign. Multiply answer by 2,560. Y equals 0.625. The amount of available chlorine after 12 weeks is 0.625 ounces, or a little more than a tablespoon.